Bonjour à tous. Hello, everyone. My presentation today focuses mainly on the assessment of potential impacts of oil and gas development on shallow aquifers in the Fox Creek area, which is located in west central Alberta. For this presentation, I'll just skip the abstract. This multidisciplinary project involves many people, mainly because it became in fall 2019 one of the few federal government projects to study cumulative effects. It involves research scientists from the federal and provincial governments and university professors, as well as grad students. The study area extends over about 700 square kilometers. It is located just southwest of the town of Fox Creek. This industrial area is mainly forested and unpopulated, so there are no residential or farm wells that we can use for this study. The only water supply wells belong to oil and gas operators. Fox Creek was selected because it has been one of the most active regions for oil and gas production in Canada over the last 50 years, and it has experienced some of the largest induced seismic events in the country related to hydraulic fracturing. The regional bedrock aquifer is located in the Pascapoo Formation. It is a non-marine unit that corresponds to a complex succession of interbedded mudstone and siltstone with sandstone channels that you can see in yellow. The Pascapoo Formation is the most important groundwater supply in the province. The Fox Creek project has three objectives related to the three sources of funding. First, to characterize the regional non-saline aquifer located in the Pascapoo Formation. Second, to investigate the integrity of the intermediate zone using geochemistry and a geomechanical study. What is exactly the intermediate zone? Well, it's the zone here that is located below superficial aquifers, mainly located in the Pascapoo Formation here, and above the zone targeted by the industry here, corresponding to the Duvernay Formation. This intermediate zone thus controls the vulnerability of superficial aquifers to potential contamination that could come from activities at depth. And the third objective is to assess cumulative environmental effects, including a general study that aims to identify challenges and barriers, and that will include recommendations for improving the process and current practices. Fieldwork took place in September and October of last year. 9 monitoring wells were drilled in the study area. I'll show a map on the next slide. With depths ranging from 35 to 90 meters. Because rocks of the Pascapoo Formation is friable, wells needed to be cased. So geophysical logging needed to be done right after the drilling and before the borehole was converted into a well, and a lot of problems arose from that. Nonetheless, we were able to drill one of these wells on an active oil and gas well pad, so we were very happy about that. Drill cuttings were sampled in plastic bags for the geological interpretation, of course, as well as for geochemical analyses, and some were also put in ISO jars. Groundwater samples were also collected in each well, but only for alkanes, so for methane, ethane, and propane. The complete series of analyses will be done next summer. The locations of the 8 monitoring wells drilled on Crown land are illustrated on this map along with their total depth. 2 of these wells were drilled very close to each other, but at different depths, 35 and 50 meters. They are shown on the picture. As expected in this heterogeneous bedrock formation, each well turned out to be very different from the other, with widely varying percentages of fine-grained rocks versus sandstone, and number of fractured zones and flowing fractures, etc. A gauging station was also installed on Tony Creek, as we need this information to be able to calibrate the hydrogeological model. The objectives of the borehole geophysical logging are and were, in fact, first to identify lithological, hydrogeological, and mechanical structural conditions in the near surface bedrock. And second, to support the shallow aquifer characterization by selecting depth for screen installations, so for groundwater sampling, identifying fluid pathways and thus hydraulic gradients to better understand the hydrodynamics, and providing near-surface data sets to examine continuity of shallow to deep geomechanical properties, such as the Young's modulus and Poisson's ratio. Lithological, hydrogeophysical, and structural geomechanical logs were collected for almost all monitoring wells. You can see in the table that well 8C was not investigated as much as the others because the conditions of its walls were very uncertain, so we didn't want to lose expensive equipment. Of the 9 groundwater samples, only one contained methane, the one from the deepest well. Its origin was clearly microbial according to the isotopic analysis. Surprisingly, the CO2 levels were quite high. This could happen if the rocks contain carbonates, but they don't. So we will continue to look for the explanation with the upcoming samples, especially that the full set of conventional geochemical analysis will be done next summer. None of the ISO jars contain enough methane to do an isotopic analysis. However, very little rock had sometimes been put into the ISO jars by the consultant, as if a gas shale reservoir was being sampled, unfortunately. I will now present the results of the two-dimensional hydrogeological model that has recently been completed. This figure presents the final, thus calibrated version of the model. It includes the upper 4 formations, which are from the oldest to the youngest, the Wapiti, Battle, Scollard, and Pascapoo formations. These non-marine formations are composed of sandstone, mudstone, and siltstone, except for the Battle formation, which is mudstone dominated and thus considered nearly impermeable. The Battle formation, however, is very thin and can even be discontinuous as it was completely eroded in some regions. This figure also illustrates that the Pascapoo formation was divided into 2 layers since the upper 100 meter is more fractured and thus more permeable. The upper part of this formation was further divided into 3 sections in order to have the simulated water table close to the water table obtained from the piezometric map based on available hydraulic conductivity data, of course. The figure on the right shows the final simulated water table. The fit with the interpolated water table is considered relatively good with a root mean square error of 7%. It is important to mention that the observed water table shown here was extracted from the piezometric map, which was obtained from kriging within external drift using topography as a secondary parameter, as groundwater level data are not well spatially distributed in the region, giving a lot of weight to the topography where there are no data available. Therefore, the real water table is probably lower than what is shown here on the figure, especially just north of Tony Creek where a mound is present. The last figure on the bottom right shows, as expected, that flow is mainly concentrated in the upper part of the model, and especially in the first 100 meters where higher hydraulic conductivity values have been assigned in the Pascapoo formation. It also shows that there are nearly 2 distinct hydrogeological models separated by a nearly impermeable unit, the Battle formation, identified by the blue arrow on the right. As this project aims to assess potential impacts of activities carried out at depth on shallow aquifers, we wanted to see if or when upward flow could occur in the system. We thus simulated a window in the Battle formation, which was designed based on cross-sections of the provincial geological model in this area. For the base case scenario, where all values are the same as those used for the model shown on the previous slide, except for the window, we see that groundwater is always flowing downward. The figure on the right now shows the conditions for which we begin to see upward flow. Hydraulic heads in the Wapiti Formation must be increased by more than 100 meters compared to the base case. So this seems quite unlikely. However, the provincial map on which the hydraulic head values on the Wapiti of the Wapiti Formation were taken for the base case scenario does not have much data, and an area just northeast of our study area shows this range of values. So this possibility cannot be completely ruled out. A two-dimensional coupled surface water, groundwater model and a 3D hydrogeological model are currently under development. The geomechanical study aims at a better understanding of the behavior of the intermediate zone that plays a major role with regards to upward fluid migration. Many different types of geomechanical tests were performed last year on 53 core samples from 2 oil and gas wells. The results of these tests provide measurements of static elastic, such as Young's modulus and Poisson's ratio, and strength parameters. These values were used to calibrate continuous profiles of these parameters estimated from well logs in 1D, one-dimensional models, as you will see on the next slide. 1D mechanical earth models have been completed for 4 wells for the upper 3.5 kilometers. They provide, as I mentioned, continuous profiles of mechanical properties of rocks, but also of pore pressure and 3 principal stresses, vertical and minimum and maximum horizontal stresses. The profiles of mechanical properties of rocks were estimated from well log data and calibrated using the results of the available geomechanical tests, shown here using dots. The pore pressure and minimum horizontal stress profiles were calibrated using the results of drill stem tests and diagnostic fracture injection tests. A 3D static geomechanical model was developed in Petrel. It was completed in 3 steps. So in a nutshell, 3D structural modeling, which consists in building the structural model for the entire sedimentary succession based on the results of the 3D seismic interpretation. Then properties modeling. So properties were propagated within the 3D structural grid between the available wells. And 3D finite element modeling, which led to the estimation of the 3 principal stresses. A 3D dynamic model will be developed in the coming months, which will allow us to analyze the default mechanical instability caused by changes in fluid pressure associated with hydraulic fracturing. The objectives of the general study on cumulative effects are, first, to provide an overview of what has been done worldwide so far on cumulative effects. Second, to learn about opinions, views, and concerns of indigenous communities on cumulative effect assessments, and take note and become aware of their recommendations. Third, identify obstacles that consultants or practitioners face while conducting cumulative effect assessments. And fourth, make recommendations to try to improve the current process. To reach its objectives, 15 semi-structured interviews with environmental assessment practitioners from different provinces and federal government managers were conducted, and 5 focus groups with indigenous communities and committees from Quebec and Alberta were held. The collected information is currently being analyzed using a specialized software. All groups shared similar views on many challenges and barriers, including a positive point for us. Cumulative effects assessments would be better conducted when the federal government is involved. But there's a severe lack of data, and sometimes it is simply due to a lack of accessibility. There are sometimes too many public consultations for proposed project that can lead to consultation fatigue in the indigenous communities due to lack of resources, and that can lead to a decrease of their level of engagement. We are simply asking too much in too little time. And there's also a lack of consistency or clarity in the language that does not help at all. Finally, here's a quote from a consultant we interviewed and who wrote a guide on this topic. He basically said that no one has the knowledge or the data to do a thorough cumulative effect assessment at the moment. And the more I work on this topic, the more I agree with him. So as government researchers, we definitely need to do more work in this area and try to find